And now we are recording. So, as I said, this is Algebra 2 Lesson 1.7, Solving and Justifying Multi-Step Equations. And again, you're going to take notes on this in your math notebook. You will also explain how you could use what you learned to solve a problem that you think is similar in just 1 or 2 sentences. You must have it uploaded to me by Sunday. And by the way, today I am trying to, I actually opened and looked the Synergy link. I think I can get that set up for a Dropbox as well. So you can try either again, and whichever works best for you, go ahead and do it. But by next week, all of my lessons I expect to be in the Dropbox. And I'll announce that periodically this week. And so starting really with Unit 2, that's, that's starting next week. Starting next week, we'll do it. So again, remember that your header at the top of your notes has to have your name printed, both first and last, the date, the period, and the subject. Okay. All right. And again, my email address is joshua.warren@tusd1.org. Okay. All right. You want to take a picture of that? I'm going to give you 10 seconds. Please make sure that you take a picture of the page. Okay, 10 seconds are up. Okay, so this lesson is about solving and justifying multi-step equations. So everything you do in math, you can justify. I mean, that you have to think about. And what really justification is all about is understanding what is it you got to do next. And you can tell, or you should be able to tell, just by what you see in the equation when you start. So again, it's a good idea to use a calculator if you have one, although today's is a little bit simpler. And again, this lesson supports Algebra 2 IXL Lesson B3, Solving Equations, Completing the Solution. And again, you will find that already in your lesson links calendar. Make sure you've refreshed your Clever so that you can get into that and you should be able to access it. Now, to complete the process of solving an equation, really the bottom line is you got to understand what changes from one line to the next. I mean, that's really what it is. You got to understand what changes from one line to the next. So it's just a, visualize it, look at it. What is it telling me? What is it I got to do to to go to the next thing? And your guide to this is, first of all, simplification and then undoing. So when you simplify, you do that if an equation that you start with has like terms. So you would simplify them using PEMDAS. You know what PEMDAS is. We've gone over this a number of times in our videos, and it's an old thing for you, I'm sure, because you probably had it in middle school. And so whenever you want to use PEMDAS, it's because you have like terms on the same side of an equation. Okay? It's on the opposite side of the equation, meaning that it's a cross on the other side of where the equal sign is, whatever it is, it's the same. Maybe you have x on the left side of the equation equals 5x plus 3 on the other side. You want to get the 2x and 3x together, but they're on opposite sides. That is a form of simplification, but you have to do that with undoing. So you start out with simplifying like terms on the same side of the equation. Then once the equation is simplified, you will use undoing, which is a reverse. Again, this is a reverse PEMDAS. So you're going to use the reverse of PEMDAS to isolate the variable. In other words, get it by itself. Okay? So if you have an equation that's 2x equals 3, you want to isolate this variable by undoing. In this case, so you would undo, and the way you would undo, this is your justification now. Divide by 2 on both sides. Okay? And so you would do that, and you get x equals 3. And now you see the variable is all by itself. That's what I mean. This is your variable. Get it by itself. Okay? All right? So, go ahead and take a picture of that. I think you can see it, all of it on the page. If you have not, I'll give you 10 seconds to take a picture. Looks like Mr. Bales got knocked out. He's coming back in. Mr. Bales, if you are there, hopefully you are. Let's see if I can see you. Yeah. So Alex, you take a picture of that page. You just walked in. So make sure you get a picture of this. I'll give you 5 seconds. Okay. All right. So on to the next. Okay. So throughout the process of solving the equation of the for the variable, this should be solving the equation for the variable. There, I wrote that wrong. Even when you have moved to undoing, you may encounter like terms. So let's just say you started in, you had some undoing, but when you simplify, when you undid, you find you've got 2 terms on one side again. Something in the undoing created that. Sometimes that happens. Then you stop and use PEMDAS as necessary to simplify the like terms. It'll be more apparent when we get into some of these. Okay. All right. And then lastly, this just takes back to the front. So you can see from looking at all of this, what I said at the very beginning, I'm now going to say at the end. To complete the process of solving an equation, understand what changes from one line to the next. That's really the key to justification. Okay? All right. Take a picture of this. Give you 10 seconds. Okay. Moving on. So here's an example. So I'm going to do a few examples. And this is really basically how the process should look for justification down here when we get to it. So you're going to complete the process of solving this equation. And in this case, this is kind of a scaffolding thing. What we're doing here is we're going to show you what the justification is in some cases, but not in all. This is the first example. I'm just going to write justification over here. Pardon me, somebody's after me. Let me see if it's somebody who's locked out. Let me check. It's a local call. Hello?
Hello, USC families and staff. Access to Zoom has been restored and is functioning. However, we understand Clever is having intermittent issues nationally. Please keep trying as they are correcting the issue as we speak. Please note, school is occurring today for all students. We will send out an update as soon as we have more information. Thank you.
Okay, so that was a phone message from TUSD. It's one of their robocall messages saying that both Zoom and Clever have been having issues. And if you get knocked out, keep trying to come back in. Just bear in mind, we will work with you. I mean, if we have to move something around, we will. But I will have this stuff pre-recorded, and you can get back into it, I'm sure tonight, and whenever it resolves, you will have the links. And so you have all the way till Sunday at 11:59 p.m. again to upload to me your notes and to complete your lessons. So you're in good shape here, even though the internet is screwed up. I'll continue to blame the Republican Party, but no, I'm being bad. Okay, so let's see. So complete the process of solving the equation, fill in the missing term on each line, and then it also says simplify any fractions. All right, so here's your equation, 20c plus 1 equals 20. All right, so without looking at the right-hand side, which tells you what to do, you kind of have to look at this and you have to say, well, what is it what's happening here? So they're telling you, okay, well, the next step here is c plus 1 equals something. Well, if I was looking at this the way it is right here, and the 20s disappeared on the left-hand side, what's going to happen to the right-hand side? Well, if I was trying to undo this without simplifying, I would divide 20 times c plus 1 by 20. So I would do this. Okay? And think of the dividing sign as being over here as well, because these two numbers are 20 and parentheses c plus 1. They're all multiplied together. That's considered one term or one number. So I can divide by 20, and if I do that, I get 1, right? And I'm going to divide by 20 over here, and I'm also going to get 1. Okay? But this says c plus 1. It says c plus 1, and down here I see c plus 1. So there you go. It says divide both sides by 20. So I'm going to do that now. And let Mr. Cross in. And so I'm going to get c plus 1 equals c plus 1 equals 1, right? If I divide both sides by 20, 20 divided by 20 is 1. And I divided this side over here 20 by 20, and I've got left. I have c plus 1 left. So this is 1 times c plus 1, so that's c plus 1. This is 20 divided by 20, which is 1. Okay, so that's what happens when I divide both sides by 1. All right, so then I'm going to subtract 1 from both sides. Now, when I do that, of course, it's eliminated over here. But what happens if I subtract 1 from 1? What is 1 minus 1? So I'm going to ask somebody here. So let's see. Would everybody please take a look at this problem? If you took 1 here and you subtracted 1 from it, what's 1 minus 1? So Simona, can I call on you to tell me what 1 minus 1 is? It's kind of easy. Can you unmute? 1 minus 1? Yeah, it's just 0. So that's your answer there. So I know that it's a little weird, doing these justifications that are around this, and a little awkward. But once you see what they're doing, it turns out to be pretty simple. So let's do a few more. So we're going to. It says to complete the process of solving an equation, understand what changes from one line to the next. So we're going to go through and just look at the explanation, and this is what we covered. So this is sort of a repeat of what we did just up front. So same equation, start at the top with the first and second lines. So here's the first and second lines repeated. 20 times c plus 1 equals 20, and then we said c plus 1 equals, well, we divided by both sides, divided by 20 here, divided by 20 here. Here they are doing it mathematically down here. You can see they did it just the way we normally do it. And so this is, again, justification. We divided both sides by which is what they put up here. Oh, Lord, this must be... I'm going to ignore that one. Another phone call. I thought it was a school. And that leaves us with c plus 1 equals 1. And the missing term is we're going to subtract 1 from both sides. So subtract 1 from both sides. Why? Because what happened here, once we got to c plus 1 equals 1, we then said c equals, well, the missing term would have to be 1. And why don't you take a quick picture of this? Well, we've finished the justification on the next page. So I'll give you 10 seconds to take a picture of this. Okay. So, all right, here we did it. Subtract 1 from both sides because the missing term was the 1. And so that means that c's got to equal 0. Okay? And then here's the actual math that was done. C plus 1 equals 1. And you subtract 1 from both sides, you get c equals 0, and the missing term is 0. Okay? All right, you want to take a quick picture of that, you may. I'm giving you 10 seconds. Okay, the 10 seconds is up. All right, so now we're going to just do some problems manually. So I've got an equation. X minus 6 minus 12 equals negative 10. All right, and then the next step, it just says x divided by negative 6. X over negative 6 is the same as x divided by negative 6 equals 2. So what did we do here? Well, the 12 is gone. The negative 12 is gone. And over here, negative 10 is gone. Okay? So if we were thinking about what would we do with this equation to get x by itself, we would use PEMDAS. So think PEMDAS. I'm sorry, not PEMDAS. This is undoing. So undoing, we would use SADMAP. Okay? So we aren't doing really anything different than we normally do. We just look at this and we say, got a variable over here, it's in a fraction, and then you subtract negative 12 from it. SADMAP says the first thing you would do is subtract, so you're going to add 12 to both sides. You've got to add 12 to both sides. So that's the missing thing. Add 12 to both sides. So when you do that, plus 12, plus 12, then x minus 6 is all of a sudden by itself over here on the left side of the equation, which is it is. And positive 12 and negative 10, or 12 minus 10, is 2. And there's the 2. Okay? So all we did was add 12 to both sides. That's what goes on this line here, which I wrote a little bit high. So now, the next thing you got to do is you got to go from x divided by negative 6, or x over negative 6 equals 2. We want to know what x is. So what we have to do is we have to, since this is a fraction and the negative 6 is in the denominator, we have to multiply times the reciprocal of 1 over negative 6. So just to make this very clear, if you want to set this upright, you would want to think of this as 1x over negative 6, and then you're going to multiply times the reciprocal of 1 over negative 6, so that's 6 over negative 1. Okay, and so when you do that, negative 6, this is negative 6, pardon me, positive 1. So negative 6 divided by negative 6 is 1, and 1 over 1 is 1, but there's an x up there. So I'm going to go ahead and multiply times negative 6 over 1 here. And that's multiplying both sides by negative 6. Now you're going to say, well, you just did it by a fraction, negative 6 over 1. Well, negative 6 divided by 1 is negative 6. I'm only keeping it in fraction form because I've got x over negative 6 as a fraction, and we want to keep it consistent. But it's really just negative 6. So again, negative 6 and negative 6 cancel. This is just x over 1, which is the same as x. And then on the other side, you're also dividing by negative 6. So, you know, if you, I'm sorry, not divide, multiply. We're multiplying here. So you're going to multiply times negative 6. So if I multiply 2 times negative 6, 2 times negative 6 equals negative 12. So this is x equals negative 12. And again, I'm sorry that it looks kind of messy, but this is 2 times negative 6 because I was multiplying again negative 6 to the x. To get rid of the negative 6 in the denominator. Okay. All right, so that's undoing, and with fractions it's a little messy, but there you have it. There's your answer. Okay, next problem. Negative 4 times d plus 7 equals negative 4. So I'm looking at this, and I look at the second one, and the second one is negative 4d minus 27 equals negative 4. Well, it looks like what they did was they distributed. So this was simplification. This was using PEMDAS. We looked to see what's in the parentheses, couldn't do anything with that because they're unlike, but then we multiply after looking for exponents. There's no exponents, but multiplying is here. So negative 4 times d and negative 4 plus 7, so this is distribution. And when you do that, negative 4 times d is negative 4d, negative 4 times 7 is negative 27, and that equals negative 4. Okay? So what did we do here? We distributed negative 4 to d plus 7. That's what we did. And so now you can get a better idea. It's a little clearer. You can see what you're doing. All right, so now you look at the next one. Here's what we ended up with. Negative 4 minus 27 equals negative 4, but below it, it just says negative 4d equals something. Well, we must have done undoing, so we must have added 27 to both sides, okay? And, oops, I typed that wrong. Add should be 27, negative 27. Well, add 27 because opposite of negative 27 is add 27. So there was a typo there. Just change that to 27 to both sides. So, all right, so if I add 27 to both sides, again, this is eliminated. On the left side, negative 27 is eliminated. But when I add 27 to negative 4, well, again, you know, use your calculator if it's an issue for you. But it's really the same as 27 minus 4, so that's pretty easy. And so you get 27 minus 4 is 23. So you're going to write 23. Okay. All right, and then it says divide both sides by -4. Okay, so, whoops, let's not look at that. Let's pretend we didn't. Just we're looking at this, and notice here we get to D. So obviously we got -4 out of there. And obviously that's the last thing we would have to do. We'd have to divide both sides by -4. So they give this to you. Okay? Okay? And so go ahead and do that. Divide by -4 on the left, and -4 divided by -4 is 1. You're left with 1D. You divide 23 by -4. Oh, that's a nasty looking fraction. Well, let's see. When we started these, I think we talked about fractions, and it just said to simplify any fraction. So if we can simplify 23 over -4, we would, but we don't. 23 is a prime number. -23 is, let's do this again. 23 over -4 means you've got D equals negative, and we'll make the whole fraction just negative, 23 over 4. Okay. So 23, as I said, is a prime number, so you can't divide anything into it other than 1, so you can't simplify this fraction. It's as simplified as it's going to be. Okay. All right, so I'm going to move this down just slightly. All right, go ahead and take a picture of it. I'll give you 10 seconds. Okay, so that's it. We're done. And so I'm going to stop the recording now because it is done. And you will move on to your IXL